something they never tell you in superhero school is roofs are nasty as hell. Hey everyone, let me start off by saying thank you for the amazing response to my last video. The mixture of support and advice in the comments really was astounding, and it's clear to me that many of you want me to succeed, and that means a lot. A couple of you have already booked consultations with Dragline Dynamics, and I've gotten a few sponsorship offers which I intend to take. Like I said in the last video, we're going to need all the help we can get. I'm still looking into things like NSF grants and angel investments and the like, but I've also been really busy getting ready for my dissertation proposal. Speaking of which, as I'm recording this, it's now Halloween, hence the costume at the beginning. And we just had a celebration for my lab mate who defended her thesis today, and she did a fantastic job, and we're all really proud of her. I just thought I'd include that. I thought I could give you guys a little video this week to show my appreciation and also bring some of the new people up to speed. I'm going to show some never before seen test footage of some of the mechanisms I've been working on over the past several months, and we're going to take a break every now and then to relive some of my old projects and discuss how my mindset has changed over the past decade. So sit back, relax, and let me tell you a little bit of my story.
This video is sponsored by Dragline Dynamics, LLC. Are you a cosplayer or a real-life superhero? Does your supersuit need some transformative technology? Protect your secret identity with Symbolite. Order now at www.dragline.tech. Or, if you want superpowers for real, consult our expert who has graduate degrees in engineering and a decade of research experience. Schedule today at www.dragline.tech. Dragline Dynamics is democratizing technology for modern heroes, and that means you. I started off my independent engineering work in 2015, when I was 15 going on 16. It was during this year I built my first usable fluid shooters. These were wrist-mounted, operated electronically by solenoid valves. Although they were bulky, they did experience a miniaturization in the summer of that year. However, by far my favorite project from this year can be found in this video. This was a cool looking prototype, albeit somewhat unuseful. It had the capability for audio recording and playback, temperature sensing, CO2 cartridge dispensing for empty fluid shooters, as well as controlling a sixth sense device that was questionable at best. This was certainly an era where I thought I could be just like a fictional superhero if I just throw a bunch of technology into a device. But this was the first in a legacy of inventions which taught me if a device makes your natural body functions like mobility or grasping significantly more difficult, it's not really augmenting your abilities, is it? But I still think for a 15-year-old in 2015, I had a respectable amount of ambition to create a project like this. Let's move on up to the present day, where I'm tweaking my current string shooter project. As a reminder, my hope for this project is to invent a system for firing a solid line that can be retrieved in a fully resettable manner. This means that once the line is reeled in, it's immediately ready to be fired again. I want this device to be fully operable using only the arm and hand it's mounted on. Last time you guys saw me finally get a firing mechanism that was extremely powerful, so let's continue from here by trying to make this mechanism even more easy to manufacture. To me, this meant I wanted to get rid of the capstan pulley mechanisms which coupled many of the moving parts in this device. In the coming clips, you'll see me transition to a ropeless mechanism that's far more easy to assemble. I've come up with a mechanism, finally, to retract this back and forth and move this back and forth at the same time at the exact rate that I need. Check it out. Isn't that something? So this reel has the bearings on it now. There's going to be another mechanism inside here that I'll have to show you guys that'll hold the rope taut to add some tension on the rope when it's wound. You can see there's no more ropes, crazy winding of strings here. It's really hard to manufacture. This is much easier. It's not back drivable. It's just totally dependent on the motor position. I'm really proud of this. It took me a long time to figure out how to do this. I'll show the details of the mechanism in a second, but for now, this is a great start. There's still going to be a rope to like the pulley with the mechanical advantage of 3 to actually force this guy, but it should run in parallel with this bar here that's pushing the slider back and forth. But yeah, this will be much better for manufacturing purposes.
In 2016, when I was 16 going on 17, I first encountered the idea that different types of webbing devices may serve different purposes. A fluid shooter and a solid line shooter, for example, each have their advantages. So, I switched to a system of having one of each, and this is a mindset I continue in the present day. The fluid shooter is the same as the previous year, while the solid line shooter used an electromagnetic coil gun to launch a projectile and a small fishing reel to switch between the firing mode and the motorized winding mode. Sound familiar? At this time, the solid line web shooter wasn't super impressive, in my opinion at least. I had to add some initial velocity from my own arm to get it to travel a useful distance. Coil guns are hard to get right. I much prefer the powerful spring-powered mechanisms I'm developing today. Speaking of such spring-powered mechanisms, let's move back to the present-day test footage. I was having some trouble with the reliability of the mechanism that compresses the spring, as the high torque became too much for some of my 3D printed parts to handle.
Okay, I've now done a handful of tests with this new mechanism, and it's so close to being complete. The winding is great. I'll have to show you guys how I'm doing this. That's what this orange cable is for. That activates the mechanism to put tension on the rope or not put tension on the rope. Oh, it's so close. So the tight winding works great when the tension is put on the rope. When it goes to shoot, the tension is pulled off the rope. And the shooting happens so powerfully, and the winding happens perfectly. And it just needs a few tiny little tweaks. And one of those tweaks is I'm finding that the motor is stalling. So I had one motor break already, and so now I switched the motor. But now, yeah, this has been completely rounded out. The shaft started spinning inside here, which is not good. So I really depend on, because this is made of plastic, which kind of sucks actually, I really depend on the windings going around here to compress this and hold it tight onto the motor and stop that from happening, but I just didn't have enough winding, so I'm going to need to replace this cable here, because that's what that cable is. I need a longer one again. The very last problem that I'm seeing here, I definitely need to make the movement of this more precise so that it perfectly interfaces with the coupling gear right here. But yeah, we're very close. So exciting!
In 2017, when I was 17 going on 18, I made a number of successive advancements to improve the size, usability, serviceability, and flexibility of the fluid shooter. I started using smaller solenoid valves, which had a pressure rating just on the edge of what my propellant's vapor pressure was. This didn't make things easy, but I did come up with designs where everything, including the solenoid valves, were completely replaceable. I was becoming an adult. It was time to stop gluing things together. I had both a 2-part and 1-part variety prototyped as well. Eventually, I was dissatisfied with localizing heavy and bulky valves on my wrist, so I opted to move them to my back, alongside the fluid pressure vessel. This innovation highly improved my personal agility, and as long as I was standing upright, I didn't have to worry about holding my arms in the correct orientation for proper function. In more recent years, I've opted again to move things closer to the wrist, as then the device itself becomes more manageable in the moment. The key to this, in the modern era, is to miniaturize valve mechanisms using principles of fluid mechanics and to provide creative solutions for the orientation problem. I still look back on this particular summer fondly, and this invention is a big reason why.
Okay, so we've got it all put together here. So I'm not going to show the full view, but you'll see it pull the entire rope out very quickly if it works. Come on. Oh. Get stripped again if I just push on this. Maybe? Yeah, I mean, it's powerful, but the motor couldn't quite get it there this time. Let's test the winding now. I think we should be able to do that. So, it's still coupled there. Yeah, so you see this is, right here, is not totally matched up. So we gotta figure out that part. But other than that, let's check the winding here. So it's tight now. We're winding tight thanks to this mechanism that I built in here. The magnet's getting caught on stuff, of course. Stop it. Okay, here we go. Yeah, so it's winding nice and tight now. Alright, so that locked into place there. So that's nice. And I mean, we can even fit more rope on here now, more than 5 feet, now that we're winding tight. It's just this motor issue here that we have to deal with. In 2018, when I was 18 going on 19, I was finally studying engineering in college. This provided numerous revelations about mechanical and electrical design, and most valuably, exposure to other ways of thinking. However, I was still of the mindset that I would need some kind of armored suit, and under that assumption, I made what became my signature uniform for many years. Layers of Kevlar and neoprene on top of spandex provided durability and flexibility. Coupled with this was a spiritual successor to the 3 previous inventions discussed. This used an arm-mounted touchscreen interface to select different types of web fluid for my left arm, as well as a coil gun-powered fishing line shooter with a winding mechanism that I designed this time. I will say the fluid system here worked very well, but the solid line shooter still needed a lot of work. At some point in this year, I had to separate the superpowers from the supersuit, which were originally designed to be permanently fixed. The suit itself lived on to see future powers integrated. Okay, so I've just made the pulley a little bit bigger, and what I'm hoping that that'll do, it'll make the rope be wound tighter around it, and that also adds more material, so it's harder to deform from the shaft that's inside of it. It got close. The latch is almost fully there. Let's see how tight that cable is. Definitely very tight. If I press on this, indeed. What happened there? That was a little snag on the rope's part. But we still can't quite get tight enough around this pulley. Make it maybe slightly bigger. Maybe that'll work. I don't know. Let's try it. Okay, so I've basically just tried to wind it tighter around the pulley, and I've also wound it when the mechanism is all the way back here, which means as it goes this way, I think it'll be even tighter because this pulley is slightly oversized now. So let's just see if this can do it. And if not, I have a couple more things I can try to fine-tune this mechanism. Nope, not quite. It's almost pulled all the way here. Let's do this again. Yeah, so still not quite. Really unfortunate, honestly. We're gonna have to figure something out here. Okay, so if I'm being honest, I have noticed some slack in the rope when I've been trying to use, the rope that's wound like this in order to push this forward. But of course, this mechanism with the screw that goes like this here, this one, the one that I'm very proud of, also pushes this back and forth, right? And it's hard to match up the rates so that they're exactly identical. And basically what I want is when it's moving forward, the rope needs to be pulling it forward because that's the mechanism that can withstand high tension, that balances this, that doesn't only push on it on one side. The screw is just so that this can move backwards. And so what I found is that this mechanism is doing the pushing and the pulling, and the rope doesn't end up doing that much. It doesn't end up contributing enough force. The rope isn't in enough tension, and so the pulley breaks. This arm here that connects the slider, this part here, I've changed it so that there's a little bit of a slot here so that this can move back and forth. My expectation is it'll pull, backwards like this, but it won't be able to push forwards because it will always be sort of in the middle here, and the rope will be doing the pulling. So this is before, it's just a hole. Now it's a slot. Hopefully a good solve for the issue. We're gonna try it out. I just added that new mechanism with the slot. You can see it there. And I've assembled everything, wound up the rope. The winding worked really well this time, so that's exciting. We're gonna see now if that little change was enough to stop the capstan pulley from stripping on the motor shaft. Here we go. Please. Okay. It's okay. We'll figure it out if it doesn't work. Happen again. Is there slack? Seems very tight to me, just to be sure. I think maybe... Gosh, I love that. I love it. Maybe there's something else going on here that I'll have to take a look at. You know, I really can't figure it out, so I'm going to just try printing this capstan in a different material. See if I can get it to not strip. Maybe if I do nylon or ABS or something. I finally started thinking about what could actually be useful in 2019, when I was 19 going on 20. This was the first year I attempted to create my own valve for fluid shooters, as I was dissatisfied with what was commercially available. On the solid line side of things, I created a bola shooter powered by flash cotton. This is the only combustion powered device I have ever created, and while I loved how much power it packed, the volume and nature of the sound it produced did not bode well for the future of devices like this. That's why I'm now dead set on using spring-powered propulsion, like with this device. Okay, so here is the next thing I'm going to try, which is a pulley that is, again, slightly bigger, but also made out of ABS instead of PLA. It's that bright green material, that's ABS. Everything else is PLA. You know, I think for the final versions, I'm thinking about PETG. If this doesn't work, I don't know. We'll see. Here we go. It worked! Let's go! Oh my goodness. Finally, with the stronger capstan in place, the mechanism was complete. This meant it was time to add the electronics. With the pandemic in 2020, when I was 20 going on 21, I found myself with time to think and innovate. As a result, I made my first public attempt to create a continuum arm, or mechanical tentacle, and created a solid line shooter in which single-shot cartridges could be easily replaced. It was the first time I realized how much propulsion I could get from a compression spring. I still think this device is super fun. You can actually still find the 3D printable files for both of these projects on my secret drive for $5 tier patrons. Inspired by Ben Riley, I also developed a motorized carousel version of this shooter, motivated by the fact that each cartridge only has a single shot. That was a really fun design project, and almost every design step is chronicled in my R&D series from the fall of that year. This year also saw the finalization of a sleek, waterproof power pack, a wearable power source that was remotely controlled. This eventually became integrated with my suit and was meant to be part of a modular system in which new gadgets wouldn't require their own power source. This device still exists and works today, and I will use it again if I can find a reason. At the end of this year, I finally found time to optimize, through extensive qualitative empirical observation, the webbing formula in my fluid shooters, such that a solid strand could be fired from them. This recipe is still my go-to. I've assembled, or reassembled rather, a new version of this mechanism, and the only difference really is that I have a limit switch here, and that will allow me to sense when the spring is fully loaded and to stop there before firing, so that when you hit the trigger again, then it just fires immediately instead of having to load all the way up. Yeah, and you can see I'm assembling the electronics here as well. Ooh. We've got the little brain here, that's a QT Pi board that's compatible with Arduino. Motor driver here, H-bridge, dual H-bridge driver that will drive both of these motors. So we're going to take an input from the limit switch and from the trigger and output to these motors here. So you can see I've got it all wound up. I'm going to do one more firing test. As always, there are things that I would like to improve, but yeah, this will be good to get the electronics working. In 2021, I finished my bachelor's degree, around the time I was 21 going on 22. The following summer, I first had the idea for dragline dynamics, and I knew I had to step things up. I wanted to improve upon my continuum work from last year with various tentacle designs, relying on the properties of flexure mechanisms to enable very specific degrees of freedom. I have a great video on this that I highly recommend. In recent years, my exposure to professional continuum robotics researchers has opened my mind to several new ways of thinking about mechanisms like this, and I'd love to revisit this project at some point. On the webbing side, this year I performed successive simulations to tweak the geometry of my custom valve, with the goal of maximizing the outlet velocity. This allowed me to miniaturize the valve and place it and a 3-ounce pressurized fluid reservoir entirely within a wristwatch. This innovation was huge, and it's still affecting the nature of my inventions today. This is what motivated me to get my own CNC for machining these aluminum parts in-house. I do plan to sell devices similar to this on dragline.tech soon as I can fully optimize them for consumer use. In 2022, when I was 22 going on 23, I realized there were some innate shortcomings with a fluid shooter system. For instance, in cold weather, the vapor pressure of the propellant drops significantly. This led me to design an electronic heating system with automatic regulation, keeping the fluid reservoir at a desired temperature. I decided to build this advanced fluid shooter as several modules that compose a wristband, with the main unit providing housing for the same aluminum wristwatch model from the previous year. I thought it was a really cool idea to augment a previously successful project, so I decided to add another augmentation, electronic valve actuation. This is a capability I am still trying to miniaturize to this day, but back then, I used a motorized mechanism which provided enough mechanical advantage to generate a high enough force to depress the valve. Now, electronic actuation goes hand in hand with an electronic trigger, so this year, I also began my journey to revolutionize the trigger. Palm triggers, while cool in theory, interfere with hand activity, so I felt it was time to ditch those. I created a glove where each finger is individually sensed. This meant I could calibrate the device to only fire when the correct hand signal was performed. Nowadays, I'm interested in miniaturizing this further by using machine learning to interpret the sensors in a wristband. This project is ongoing and will serve as an interface with a wide variety of devices, including this one. Got my new fume hood here. Nice little setup. You can see a reel about it on my YouTube shorts or on my Instagram. Come on. Yeah! That little mechanism that I have inside here that clamps onto the rope, it might be clamping a little too tight because it's having some trouble winding, and I did figure out, in fact, that it is the fault of that little clamping mechanism. So we can retract this mechanism here. Maybe let's not retract it all the way and still wind tightly, but not too tightly. Yeah, see, that's not tight enough. It's doing okay, and the motor starts to have trouble around here. You can do this. Just keep. Ugh, that's kind of annoying. This can't be good for it. Yeah, well, also as this winds and the radius, you know, as there's more rope, the radius of the lever arm increases, and that adds more resistance as well. You could maybe actuate this motor to move a little bit this way as that one moves that way. That's possible. That is a possibility. I'm wondering if that's something that I could do in code, a software solution. What do you know? Okay. The advancements you saw in this video for this project are several months old at this point. This was an important stage in the development of this project. At this point, I had already started to complete the electronics and did some final tests of the mechanism, but the reliability of the spring loading remained an issue. Even after trying to further increase the rigidity of the capstan by 3D printing it with stereolithography, I began to realize I needed another overhaul. I eventually went back to the drawing board, but unfortunately, you'll have to wait to see what I came up with. But don't worry, I completely did away with any cable-driven mechanisms. In general, these mechanisms are effective in theory, but all experienced engineers know their ease of assembly and serviceability are at an all-time low. This is the reason why so many cable-driven robots have existed over the years, but none have made a dent in the industrial robot market. In 2023, when I was 23 going on 24, I began working on several different smaller projects. Amongst these was a revamp of the fluid shooter from the previous year. While working on this, I was thinking about how to solve one of the other innate issues with fluid systems, that being the orientation problem. Finally, I came up with a solution, and I implemented this into a prototype that was again actuated by the glove. The orientation fix seemed to really enhance the performance of the device, as now pure liquid is being propelled, rather than liquid mixed with vapor. I also made advancements with miniaturizing the electronics with this prototype, using a smaller microcontroller than I had ever used before. This was a somewhat frustrating year, as I had planned to complete many more projects than I had time for, but since I've learned to be satisfied with all of the cool stuff I am able to do. Looking back, this was a super innovative year. Finally, we reached the current year, in which I turned 25 and finished the third year of my PhD studies. Symbolite was something I had envisioned a few years before. The idea itself was easy enough to make. There are several ways to get it done. However, in 2024, I finally figured out a quick way to manufacture these flexible lighting fixtures, a huge leap forward for Dragline Dynamics product development, and for finalizing my current fit. In completing this, I finally realized it was time to start the dang company, which, thanks to my favorite project from this year, a super reliable wearable repelling device, many of you are now aware of.
It's been a really long journey, but I'm pleased to say I'm excited for the road ahead. So what'd you think? Let me know in the comments if you want me to go into a little more depth with any of these projects. And don't forget, all you need to do to support the channel is subscribe. Thank you to my Dragline clients. I'm really excited to continue working with you. Stay amazing, y'all. And remember, there's still time to vote before November 5th.